Section 4.5 Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH, where VTH is the open circuit voltage at the terminals and RTH is the input or equivalent resistance at the terminals when the independent sources are turned off. For example, for the original circuit on the left, and there is a linear two-terminal circuit on the left of this graph, and on the right side of this graph there is a load, and the terminals between them are node A and node B, and we can find the terminal current I and the terminal voltage V. In this case, we can replace the linear two-terminal circuit on the left by a very simple circuit with a voltage source VTH in series with a resistance RTH, and the current I and the voltage V will keep the same. But how can we get the voltage VTH and the resistance RTH? And we can find the VTH very easy because we can get it with open circuit, just as the graph on the top. But for the resistance, the situation could be a little complex, and we should do it, and we can find it with two cases. Case 1, if the network has no dependent sources. In this case, we turn off all independent sources, and RTH is the input resistance of the network looking between terminal A and B. Step 2, if the network has dependent sources, we turn off all the independent sources, and the dependent sources are not to be turned off. Then we can add a voltage source between the terminals, and then we can calculate the resistance RTH equals VO over IO. Or we can add a current source between the terminals, and then we can calculate the terminal voltage VO, and then we can calculate the resistance using RTH equals VO over IO. And then with the Thevenin's theorem, and we can simplify the circuit like this. For example, on the top of the slides, and we find a circuit with a load. The circuit and the load are connected between two terminals A and B. And then we can replace the linear circuit with a VTH and RTH in series. And then we can calculate the current or the voltage of the load RL. That will be very easier, where IL equals VTH over RTH plus RL. And the VL equals RL multiplied by IL equals RL over RTH plus RL multiplied by VTH. That's all for this section.